Okay? Now, I will tell you I got some questions on number 4. Here's the questions I had gotten today on number 4. It was, if you just have this list of information, how am I getting this thing right here? Standard deviation for that list. Okay, how do you get the standard deviation for a sample list of data? That's when you put it into a list and you compute calc over to stats, one variable stats. Or, sorry, stat over to calc, one variable stats in your calculator. When you put this in, it will give you all of the information you need to know about your list. All right, including this standard deviation. Okay, so that's one thing I've gotten. And also, as you can see on number 4, see, I am showing this formula by hand because this was just a one sample t-test for means. Okay, so I'm wanting you to still be practiced in that and not just rely on your calculator. All right, now here we are to this number 5. What things change the size of an interval? 2 things. The size of your sample is correct. What else? What? Your confidence level. Okay. So, as you can see, for example, from this margin of error, here's your critical value. So, if you look at part A, the confidence is the same. So, what's different is the sample size. N is 25 or 75, and so if I'm going to make this bigger, then that makes your N smaller. Because N going down makes your standard deviation going up. And if this is a bigger number, then your margin of error is bigger. Okay. And B addresses the other part. B addresses if these N is the same. So both of these sample sizes were, I think, 50 for a marked amount. But the critical value is different because we had a 90% confidence versus 99. So just think of this picture here, because a 99% confidence will encompass bigger critical values, so more data, bigger interval. Okay, so that's how you tell the difference on that one. Questions there? Okay. Any questions on the 1 through 4 that I skipped over that you have checked on?
Which one was number 3? I think that was a proportion.
Number 3 is a 2 proportion, so you are allowed to do that one in the calculator. So it looked like this. Keep in mind that your large enough conditions are the greater than or equal to 10s for proportions. It is a 2 sample z-test, so see, the exact normal curve applies, normal model applies. And then I was able to do this in my calculator. Do I have degrees of freedom for proportions? No. No degrees of freedom because it's the exact curve. Okay, and so on. Number 6, the only question I got on that is how did I know this one was paired? And the answer is because, each subject took 2 tests. So, I mean, it was 1 person, 2 tests, so there's really only 1 sample. Okay, that's the only question I've gotten on that one. Next.
On number...
Go ahead. Number 7, I have an incorrect p-value on your pink papers, your pink answer keys. So let's talk about that. Number 7 is a 1 proportion problem. So I was looking to see that you can actually do the z computations by hand and that you norm CDF'd for 1 tail. Now, if you had done this in your calculator, it automatically plops out the answer for 2 tails if you put a not equal to in it. But when I did this by hand, I errored because this number is just for 1 tail, and since my hypothesis has a 2-tail alternative, then I needed to multiply this number by 2, so the p-value is 0.00765, which still actually gives me the same decision, so that was good. All right, now, next question. Did you Am I there yet? Okay. 8. I don't think I had any questions on that one. The thing I wanted to point out on 9 and 10 is to please not forget that when you make an interval, you need parameter and assumptions. You cannot leave off the P and the A of the panic model and just do this part right here. Okay, and just do the interval. Actually, you might even leave off the N. You do not leave those off. Now, this part here is not required, but I do want to see this when you have one sample. Remember, I'm forcing you to still understand all the components to one sample formula.
We can check with the calculator.
Absolutely check with the calculator. That's a good idea. Okay, the reason I still make you do this is for those problems like on the multiple choices that have you know the formula outline, okay? So there's a reason for that. It's not just me being mean, although I like to be. Now, when you get down here to number 11, please notice that they gave you the variance. So that's the standard deviation squared. You had to take the square root of it to get to standard deviation of the sample. Now, I thought this problem was a little messed up in that I couldn't tell if it wanted me to do a z-curve or not. Because technically, right there, that's kind of notating the standard deviation of the population since it has a sigma. So I think it's possible. I don't know. I can't remember if the person who made these problems wanted this as their answer, but I should fix that notation probably. I went ahead and did the sample T stuff because that's what I'm going to have for you. Okay, number 12, I boo-booed. It's actually N is 9. Now, let's address this problem with these histograms. Okay, so I was concerned and perplexed with these histograms because neither one of them. Now, unimodal, yeah, I can see unimodal. So I can see unimodal. And I can see no outliers. Okay, because just one little bend skip probably isn't enough to say it's an outlier. But to me, the symmetry is an issue. I'm thinking, hello, that is pretty much not symmetric, so I'm not liking it at all. So you need to notate that, but don't ever stop on AP. Now, you certainly can, unless it is like crazy obvious, or the question is saying something like, are the conditions for inference met? Okay, then that is an indication they're giving you an out that this might not be met, and so you could be stopping, okay? But, okay, so if this is your job in real life, then when you get to this point right here, I would go, when you get and you see these messed up histograms, I'd go to my boss and I'd say, look at this problem. Do you really want me to continue? Okay, because I'm not going to feel very confident about my conclusion.
But if you had the job of preventing forest fires, would you be like Smokey the Bear?
Probably what would happen is if I was like Smokey the Bear, okay, and this was a really important thing in wildlife, and I was the head of the Wildlife Commission in the state of Texas or whatever, okay, and this was a really big deal. I'm just speculating here because I don't know. I would probably want more than just a sample of 10 or 9 to base my decision on. I would probably collect more data and see if more data still makes the shape of the population unclear. Okay, so I would want to have more data to make a final decision as to whether or not I take this information or not. Okay.
Oh.
Yes.
If that's bad, and then it's not even random, shouldn't that halt your operation?
Well, it not being random or representative, if it's not representative, then from the get-go, you're not doing it. Because why should you make any conclusion on something that's not representative of the population? period. I mean, that's the quickest way to stop it. So that always has to be assumed. I mean, you have to go with something that it is reasonable that this is representative, or else, boom, you're done. Okay? All right. This one is just the thing there going on. All right. Here we go. This is where most of our questions come up.